So now that we are comfortable with the notion of present values and future values, let us look at several applications of the concepts that we have been talking about. So our first such application that we'll focus on is to think a bit more deeply about choice sets, and especially what do those choice sets mean whenever you've got intertemporal choice problem. So why are choice sets important? Because in a lot of economics and finance, the object that we are interested in are thinking about somebody optimizing, where they're basically choosing to maximize some objective function subject to some feasible set of opportunities that are available to them, right? So, for instance, a classic problem in economics is to think about a consumer has a certain income and he goes to the market and sees certain prices. And then based on those prices and income, then he has to think about what is the best option to maximize whatever payoff that the consumer is interested in maximizing. So as part of the description of the problem, we need to first specify what are the different options that are available. And this is where the notion of choice sets come in. So first, let us think of how choice sets are modeled in a static framework. And then we will see that how the same concepts can be perhaps extended to thinking about intertemporal choices, so which means basically choices across different points in time. And we'll see that this notion of present value and future value that we have just studied, that will be of great help to us in thinking about these choice sets whenever we are thinking of it intertemporally. So first, let's look at it from a static point of view. So imagine that you have got a consumer, right? And we are interested in characterizing the consumption choice set of the consumer. So this is basically the collection of all consumption choices that are available to the consumer. Okay. So we are going to deal with the simplest possible case where you have got basically only two goods that the consumer is interested in buying. And suppose that these are going to be called commodity one and commodity two. And let's say that the consumer is thinking of purchasing X1 units of commodity one and X2 units of commodity two. So at its very simple level, the answer to the choice set characterization would have to tell us whether this bundle X1 and X2 that the consumer is thinking of buying, whether this is affordable for the consumer or not, right? So in order to think about whether something is affordable or not, we need several features about these commodities, right? So one feature that we need to know information about is what is the price per unit of these different commodities that the consumer is thinking of buying. So we are going to characterize that by the vector containing P1 and P2. So P1 is the price per unit of good one, and P2 is the price per unit of good two. Okay. And we also need information about the consumer's income. So what's the total amount of money that the consumer has to allocate among different goods? So let's suppose that that income is given by this parameter M. Okay. So the question is, when is this bundle X1, X2 affordable at prices P1, P2 and income level M? Okay. So if you think a bit about it, the answer is pretty straightforward. This will be affordable if the total amount of money that is required to purchase this X1, X2 is not higher than the consumer's income, right? So how much money is required to purchase this X1, X2? So per unit cost of commodity one is P1. So in order to purchase X1 unit of commodity one, then the total amount that has to be spent is given by P1 X1, right? And similarly, in order to purchase X2 units of commodity two, the amount of money that has to be spent is given by P2 X2. So the total expenditure that is required in order to purchase this bundle X1, X2 is given by P1 X1 plus P2 X2. So if the consumer's income M is more than this P1 X1 plus P2 X2, then the consumer can go ahead and buy it, right? However, if this amount is actually strictly greater, P1 X1 plus P2 X2 is strictly greater than M, then the consumer can no longer afford to buy this, right? So that's basically the description that we need. And so there are kind of like a couple of terms associated with the characterization of these choice sets. So we are going to call that the bundles that are only just affordable. So these are basically the bundles where the consumer exhausts all her income when they are purchasing this bundle X1, X2. That's known as the consumer's budget constraint. Okay. So this is basically the set X1, X2 says that X1, X2 is greater than equal to 0. So typically we'll be assuming in most cases that consumer cannot actually purchase a negative amount of some quantity. There are exceptions to this, but that's not the standard kind of like a scenario. Okay. And the consumer is exhausting all her income. So therefore P1 X1 plus P2 X2, which is the total expenditure required to purchase x1, comma x2, that has to be equal to m. And the budget set would, of course, include the set of all affordable bundles. So it would also take into account that there may be scenarios where the consumer is not actually ending up spending all her income levels. So then we'll replace this equality that you see here with less than equal to, right? So we can also represent this graphically. So you have got on the x-axis the amount of good one purchased. You have got on the y-axis the amount of good two or the commodity two that is purchased, right? And then we have drawn the budget constraint, which is this straight line, right? So you can see from here that if you kind of plot this in this x1, x2 space, this is going to be a line with a negative slope, right? So the slope of the line is going to be given by minus P1 by P2. Okay, so this is the black line is the budget constraint, and the set of all affordable bundles is represented by this triangle, which is below this black line and above the 0, 0 part, right? Okay. So these are all the different choices that the consumer could have chosen, right? So these options are all available. We should also think a bit about what do these intercepts and what does the slope actually indicate. So the intercept m by p1, for example, is saying what if the consumer decided to only purchase good one and no amount of good two, right? So in that case, x2 equal to 0. So the whole income, which is m, is going to be spent on x1. And so the maximum amount of x1 that could have been purchased is given by m by p1. Okay. And similarly, we interpret this m by p2 as the case where you have got that no amount of commodity one is being purchased. Only commodity two is being purchased. So the total income m is just spent on commodity two. And so the maximum amount of commodity two that could have been purchased is given by m by p2. Okay. What's the interpretation of the slope? So this is basically saying that suppose you want to purchase one more unit of commodity one, how much less of commodity two are you going to have to purchase? So in order to purchase one more unit of commodity one, you require P1 amount of money. So you need to reduce your expenditure on commodity two by P1. And so therefore you need to reduce your use of commodity two by an amount P1 by P2, right? So that's where we get this slope. Okay. So this is the scenario when you have got the static kind of setting. Okay. Now let's consider the same problem, but let's look at the intertemporal version, right? So as we mentioned, the word intertemporal suggests that you are looking at a choice problem when you are thinking about choices across different time periods. Okay. So at a minimum, we need to have the following description. So suppose that there are two periods. We specify what are the incomes received in periods 1 and 2. So suppose M1 is the income that the consumer is expected to get in period 1, and M2 is the income that the consumer is expected to get in period 2. And these are things that are known in certainty, right? So there's no uncertainty about it. The consumer has to choose how much to kind of purchase in period 1 and how much to purchase in period 2. So the C1 and C2 are the consumptions in the two periods. And these are going to be basically, eventually you'll see when we discuss the full consumer optimization problem, this will become basically choice variables. Okay. The prices of consumption in the two periods are given by P1 and P2 respectively, and these are parameters that the consumer takes as given. And finally, we need to discuss what is the interest rate per period. So that's going to be given by, again, another parameter R. Okay, so this is the description. Now, what we need to think about is what are the different feasible options in the sense of what are the different choices of C1 and C2 that are available to a particular consumer under this set of information. Okay, so that's the question that we are interested in tackling. Now, why is this an interesting objective? So oftentimes people are interested in thinking about, okay, how do you kind of like think about how much to save for retirement, for example. So that might be a case where period 1 is basically young age and period 2 is basically the retirement phase, right? So then this will be how much are you deciding to consume in the first phase, how much you're deciding to consume in the second phase, and P1 and P2 are maybe, tells us how much the price level is kind of like changing in the economy, right? Now, why is there even a choice? Because you have in the first period different options that are available to you, right? So you can decide to consume all of your income, in which case you are going to be neither saving nor borrowing. You can choose to consume an amount less than your income, in which case you'll be saving, and that saving will attract this interest rate so that you can supplement your period two income by the amount that you have saved plus the interest that you have earned on that saving, right? And also you can actually go ahead and borrow money, right? In which case you will be perhaps spending more than what your income is. But then if you're borrowing money from the future, then you have to kind of like reduce your consumption in the second period to actually prepay back, right? So if period one was like age where you were not kind of like working much, whereas period two was an age where you are working more. So this is typically the case where you are like in your 20s and after 20s, right? 30s maybe. Then in that case, you might want to take out kind of like loans from the future in order to kind of like finance your education loans or your, for example, some particular car loans and so on, right? So those would be cases where you are typically borrowing. Okay, so this is the setting. We want to characterize the choice set in this scenario. So how do we go it? So let's start by actually simplifying the problem, right? So let's ignore the prices for now. So what that means is that we are setting the price in each of the two periods to be equal to 1. So later on, we'll bring back the price, but we just want to kind of like first solve a more simplified version before we look into the more complicated version. Now, let's think of what are the options that are available, right? So one option that is always available to a consumer whenever there is an intertemporal choice problem like this is to neither save nor borrow, right? So every period, just consume whatever your income is, and that's it. So this option is always available, right? And it does not depend on what are the credit market conditions, what's the interest rate, and so on. So in this case, what will be the consumption in period one? Well, you are deciding to kind of like consume all of period one income in period one itself, and the price of consumption is 1. So therefore, the amount you are going to consume in period one is going to be given by just your income in the first period. Similarly, how much are you going to consume in the second period? Well, you have not saved nor have you borrowed. So you have got the whole of second period income to actually use for consumption in period two. Again, P2 equal to 1. So therefore, the amount of consumption in the second period is given by M2, right? So these are the two basic points that are always going to be available, right? So we can mark this point in this figure. So here we have got on the x-axis consumption in period one, and on the y-axis we have got consumption in period two, right? So notice as compared to the static problem where you had choice being made at the same point, where the two axes had amount of commodity one and amount of commodity two. Here the two axes are representing the amount you are choosing to consume in period one versus the amount that you are choosing to period two, right? And what we are saying is that this green dotted point, which corresponds to C1, C2 equal to M1, M2, is a point that is should always be on the consumer's budget constraint. Okay, so that's the first part. Okay, now let's look at some other extreme cases. Suppose that the consumer decides to spend nothing on consumption in period one, right? So that means that C1 is going to be 0 because if there's no amount of money that's going to be spent on consumption in period one, so that's basically 0 divided by 1, so that's C1. And what that means is that the consumer is going to save everything in the first period, right? So the consumer got an income of M1 and the consumer saves all of this M1. So S1 basically means how much saving is there in the first period. Okay, so you have got this M1. Once you're saving this and on the saving, you can earn an interest rate. So now that will kind of like be used to supplement your second period consumption, right? So what will be the period to consumption level? So this is going to come in from the fact that you have got an income of M2 coming in period two, but you have also got this savings that you had from period one, right? So that savings was this M1 itself plus the interest that you got on that saving. So plus R times M1. So this is the total saving plus interest rate from period one. Okay. So that means that the total income available for consumption in period two is given by your income in period two plus this income in period one plus the interest that you are earning on the income in period one, right? So this is the total amount that is available. And this is also the same as the period to consumption expenditure because the price of period to consumption is equal to 1, as we have said. Okay. So this is what you get, and you can actually plot this. So this would correspond to C1 equal to 0 and C2 equal to M2 plus 1 plus R M1, right? So notice that this M2 plus 1 plus R M1 actually has a special meaning, right? And we can use our notion that we have discussed before of future value to think about it. So this is basically the future value of your income stream where you are getting M1 in the first period and M2 in the second period, right? So just kind of like a one piece of notation. So think of M1 as the current period so income in the current period and M2 as the income in the future period, right? So that's one potential confusion where we have been using this 0 and 1. So here the current period is period 1 and the future period is period 2. Okay. So in that way, this is the basically the future value of the income endowment. So M1, M2 in period 2. Okay. And this also represents the maximum amount of consumption that is possible in period 2. Okay. So this point again is also going to be on the budget constraint. Okay. So this point is basically 0, comma M2 plus 1 plus R M1, and that's the consumption bundle when all period 1 income is saved. Now, let's look at the other possible extreme case where you have got the consumer is basically spending everything possible on consumption in period 1, right? So the consumer just wants to kind of like, live life to the full, whatever is possible, the maximum amount that is possible in period 1, the consumer wants to go there. So that means that the consumer is basically leaving aside nothing for consumption in period 1, in period 2. So then basically in order to kind of like have this type of life, the consumer would basically be borrowing from the future, right? So the question is, what's the most that the consumer can borrow in period 1 against her period 2 income of M2, right? So how do we calculate this? So let B1 denote the amount that is borrowed in period 1. Now, if you have borrowed an amount, then that means that you have to repay back that amount, plus you have to repay an interest on that amount, right? And we already know that the interest rate is R. So therefore, the amount that has to be repaid back in the second period is given by B1 plus R times B1. And the only thing that is available to repay back this amount in the future is the consumer's income in the future. So that is additional constraint. So we have got that B1 into 1 plus R is equal to M2. So we can solve for what's the maximum amount of borrowing that is possible. So that's given by M2 divided by 1 plus R. So the largest possible period 1 consumption that is possible is you are consuming the whole of period 1 income, plus you are borrowing the maximum possible that is that you could have borrowed from the future, and that's going to be given by M2 by 1 plus R, right? So notice M2 by 1 plus R also is a term that you have seen before. So this is the present value of your income in the second period, right? In terms of period 1. Okay. So therefore you have another kind of like point, which is that this M1 plus M2 by 1 plus R, which is the present value of your income if your income is M1 in the first period and M2 in the second period. So that represents the maximum amount of consumption in the first period that you could have done. And this point is also therefore going to be lying on this, right? So we have actually identified by looking at different kind of like extreme cases, one where you are neither saving nor borrowing, the other one where you are basically kind of like not consuming anything in the first period and saving as much as possible, and the third one in which you are borrowing as much as possible. And all these 3 points are on the budget constraint. What about the other points where you are not in any of these extreme cases, right? So we can also think about that. So suppose that you have got C1 units being consumed in period 1. So in that case, how much is the cost of this C1 units? Well, we still have the world where P1 equal to 1. So this means that this costs C1. And so therefore you have got M1 minus C1 amount left over. Now, notice that this M1 minus C1 can be positive or negative, right? So what does it mean? So if M1 minus C1 is positive, it means that your consumption is less than the income in the first period. So basically you have some savings left over, right? And that you can use to supplement your second period consumption. On the other hand, if M1 minus C1 is negative, then that means that your consumption exceeds the income that you have in the first period. And so therefore you need to kind of like borrow money from the future. And so therefore your second period consumption will be less than the income, right? So if this is the amount that you have saved, and this can be, again, as we discussed, positive or negative, this is the amount that has to be either kind of like, be used as like additional savings that you have that to supplement your second period income, or this is the amount if M1 minus C1 is negative, then this is the amount you have to repay back, right? And so your second period consumption is given by this expression. So in case this appears confusing, I encourage you to kind of like write down 2 separate cases, one in which you have got M1 minus C1 is positive, in which case you would be saving, and you can write down what will be the consumption in this case in the second period, and you can show that this is the expression that you will get. And in the second case, to M1 minus C1 is negative, so in which case you are borrowing, and so therefore you have to repay back some money, and so therefore you get this, right? So this is the same expression that you would get in both the cases. Now, if we just rearrange these things so that we have the C1 and C2 on one side and M1 and N2 on the other side, and then divide throughout by 1 plus R, you end up getting this expression, which is C1 plus C2 by 1 plus R is equal to M1 plus M2 by 1 plus R. Now, this is a very interesting expression because this is actually telling us something that we kind of can now translate in our language, given that we know the notion of present value. So the left-hand side, you have got that this is the present value of consumption from period one perspective, right? Because C1 is the consumption in period one, so present value of that is just C1. C2 is the consumption in period two, so the present value of that from period one perspective is that you have to divide it by 1 plus the interest rate. So that's how you get it. And on the right-hand side, you have got that this is the present value of income, right? So the intertemporal budget constraint says that the present value of consumption is equal to the present value of income. Okay, we can plot this here. So we already have these 3 points, and what this told us is that the slope of this line is a constant, and so therefore this is a straight line. And in fact, the slope of this line is given by minus 1 plus R, right? Again, where are we getting this? Basically, we are getting this from the fact that if you choose to consume one more unit today, right? So that means that you have got one more unit that you are saving less, right? And so not only are you not getting to consume this, but you are also losing out on the interest that you could have got from this one more unit. And so therefore you are giving up basically 1 plus R units in the future, right? So that's how you get the expression for the slope. And the intercept terms we have already discussed before. How do you get it, right? So this is the main expression, and this is the main thing. Okay. We can also kind of think about what are the different points at which you're saving or borrowing. So any point where you have got C1 is less than M1, those are points where you are basically saving. And any point where you have got C1 is more than M1, so basically your consumption in the first period is more than your income in the first period, are those points where you're borrowing, right? So we can actually partition the budget constraint into these two parts where you are either saving or borrowing. And of course, you have this one more point, which is C1 equal to M1 and C2 equal to M2, where you are neither saving nor borrowing, right? So you're consuming your income in both the two periods. Okay, now that we have kind of figured out how to write down the intertemporal budget constraint, in this case, we can bring back prices. So now suppose that price of consumption is P1 and price of consumption period 2 is P2. How would that kind of affect the budget constraint? So you can do the same exercise again. In fact, I encourage you to pause the video, kind of do the same exercise, look at the 3 different cases that we did, and kind of follow through. And for example, here, what would change is that if you are choosing to consume C1, this is going to cost P1 times C1. And so therefore, this will be M1 minus P1 C1. And then you can kind of do the similar analysis, and you end up getting this thing, right? So here now you do not anymore have the case that M1 comma M2 is affordable. Why not? Because suppose you were deciding to consume all of your income in each of the period. So if you are consuming all of your income in the first period, you have got basically only M1 by P1 amount of goods of commodity one that you could have purchased. Similarly, if you were consuming all of your income in the second period, you have got only M2 by P2 options that are available, right? And you can now kind of go through the rest of the analysis. So again, think about the meaning of this intercept terms, and also the slope term. What is the intuitive explanation for that? And of course, you should be able to derive this expression that you see here. Okay. All right. Why is kind of bringing in prices useful? Because then you can also start thinking about what is the effect of inflation in this framework. So what do we mean by inflation? So inflation is basically the change in the price level, right? As a fraction of the initial price level. So percentage change in price level. So basically then think of pi as P2 by P1 minus 1, right? So in this case, for example, if you have got pi is equal to 0.05, that means price is increased by 5% from first period to second period, right? If you have got pi equal to 0.10, that means that price is increased by 10% from first period to second period again, right? So once you do that, and without loss of generality, we can always normalize one of the variables. So P1 equal to 1, say, and P2 equal to 1 plus pi, then we can rewrite this same budget constraint that you saw here. So put in P1 equal to 1 and P2 is equal to 1 plus pi. So this is the expression we end up getting. And again, you can rearrange this to get an equation of the straight line where you're writing C2 as a function of C1 and the other constants, right? So let's notice what's the effect of this inflation term. So when you have got no inflation, so P1, P2 are both equal to 1 and therefore pi equal to 0, then you have got that the slope is going to be given by this minus 1 plus R, right? And this is something that you had before, right? But whenever you have got this inflation coming in, then the slope is going to be different, right? Rather than just -1 plus r, it's going to be given by actually, if you see this expression here, -1 plus r by 1 plus pi, right? So inflation is going to have an effect on the trade-off that you can kind of like do in terms of what does giving up 1 unit mean in terms of your effect of consumption in the second period. And so this is the slope, and often this is actually, this whole expression is replaced by this -1 plus rho, right? So in that case, basically this is an expression that you are going to get where this instead of this you are going to have a -1 plus rho. And so that is kind of like very similar now to the initial case where you had the budget constraint having the slope -1 plus r, right? So this rho term actually has a name, and it's called the real interest rate. So as we kind of like progress deeper and we think about more inflation, I'm going to talk about what's the relationship between this interest rate, which we have defined, the real interest rate, versus the original interest rate that we started out with, which is the nominal interest rate, right? So we'll come back to that in either 1 week or 2 weeks time, and we'll actually relate these things a bit more in terms of what is the relationship between this the original interest rate, which by the way is known as the nominal interest rate, the new interest rate that we defined, which is the real interest rate, and the inflation that we have, right? So we'll have more to say on this in the future.